Hello everyone, this is Ashwini Patil from Biostate AI, and today I'd like to introduce you to OmicsWeb Co-pilot. This is an AI-based research assistant that specializes in doing bioinformatics data analysis. Let's take a look. For input here, I'm using file with gene counts from my bulk RNA-seq experiment. And this dataset has 40 samples. So sample 1 and 20 is one group, and sample 21 and 40 is one group. And I want to know what is the difference between these two groups. So I'm asking it to perform reanalysis and generate volcano plot. So what the assistant does here is it understands your inputs, it formulates a data analysis plan, and then it writes code. And then this code is executed to give you the results. All right, so it generated the volcano plot. So here you can see that in the red you have your upregulated genes, and in the blue you have your downregulated genes. And it says here that the cutoffs it used was log to fold change greater than 1 or less than -1, and p-value less than 0.05. From here you can do a lot of different kinds of analysis. So I want to modify this plot to say that I want to use p-value cutoff of 0.01. So let's do that. All right, so here you can see that it updated the cutoff for p-value to 0.01. Now I want to change the color of these red dots to green. All right, so it changed the color of these dots to green. And you can just keep going. If you want to change some axis labels, lines, you can just conversationally just keep going, and it will do that for you. So let's do something else. I want to know what are the top 5 upregulated genes. Right, so you can see that these are the top 5 upregulated genes. You can see the log fold change and the p-values. So I want to know what this ACKR1 gene is. Okay, so here we can see that it gives us a lot of information about the ACKR1 gene, what it does, like if there is some clinical significance, so it populates that. And then here we have citations, and it produces this spider plot, which is actually very interesting because this is our Biostate AI's internal data set, which has a lot of organ data. So it tells you which organs this particular gene is getting overexpressed in. So you can see clearly here that in brain, this gene is getting highly overexpressed. All right. So I wanted to also know what all pathways these genes are involved in. So I will ask So here, what it did was it used StringDB to do analysis of these 5 genes in rats and created an output. So I'm going to go ahead and download this file. So you can see the functional annotation here. So for all these genes, you can see that these are the different pathways they're involved in. Now, let's look at pairwise rapidity. So here I just want to look at samples 21 to 40. All right, so here we can see the sample 20 to 40 on each axis, and this is a heat map. So you could see that there is this one sample that looks like an outlier. So the 2M822, this is the sample that looks a bit different. So let's remove the sample and redo our differential expression analysis. All right, so we can see that it regenerated the analysis with our earlier cutoffs and the color scheme, and it removed the sample. So here we can take a look at the logs, and then we can see that it removed our sample that was an outlier. So you guys can see how Omics Co-pilot makes it so easy to get insights from your data sets. Thanks for watching.